So this is a talk about cybersecurity, and we're actually complete novices. My colleagues and I are complete novices in the area of cybersecurity, and the task was to see if we could do something to aid a particular organisation, which would be a household name to most people here, in attempting to defend themselves against threats. So this is what this talk's going to be about. It's kind of novel. It's the only one of these projects that we've done. We've never done anything in cybersecurity before. But I want to talk about the approach that we took, which is to use an artificial immune system that we built ourselves. And it's somewhat different from artificial immune systems that other people do. But let's go back to the previous talk was about machine learning. And typically, there's no systematic way of finding novel threats. What we would typically do is, in a traditional approach, is to devise a defense once some threat has caused damage. You know, that makes the threat known. And we would develop some kind of defense using maybe logistic regression or rules or some kind of machine learning, GBM, anything like that. Because we've now got a dependent variable, we've got the threat that's happened, and we've got some descriptors of what went on. So we could develop these things. The problem with this is, of course, that you can only do this once a threat has been made known and the causes of it are known, and therefore we've got some predictive variables that we can use. But most threats that actually do work aren't known beforehand. That's the whole point, because if they're known, we have a defense for them. So the obvious question is how we change this dynamic. And the way that we decided to change this dynamic is to build an artificial immune system, which is itself an analogue of the human immune system. It can learn to defend itself, so it has a concept of a self. In this case, the self is a neural network that we built ourselves that learns about the joint probability distribution of the data. And this is only the predictor variables, not outcomes. So understanding the joint probability distribution of the data means that we could use unsupervised methods to defend against novel threats. Novel threats are going to be things that don't look like the data that we have at the moment. As well as this, we developed B-cell detectors in light of the immune thing. And B-cell detectors are never forgotten, of course, like the measles.
Excuse me, Paul. I think we are not able to see the slide transitions. So maybe switch back to this normal view and just move through the slides.
Okay. This way?
Yeah. This way, I think that way we can at least see the slides. Thank you.
Okay. All right. I'll do this. So we can develop B cells, and B cells are never forgotten. Like we have B cells. I have B cells. When I was a child, I had measles, so I have a B cell that has my defense to measles, and my body never forgets that. So if I ever get the measles virus, then my B cell says, I know about this, and mounts a defense against that. So in this case, how would we use an artificial immune system to make detections? And then I'll go to the application of cyber insurance, which was incredibly interesting for us, only because we're such novices at it. But detections by the self comes in two forms. One is anomalies, things that transactions or claims, I work in the insurance industry, so claims are kind of a big deal, that don't match the joint probability distribution. In other words, things that just look improbable. The other thing that we can detect this way are collective anomalies, which is a groups of transactions that each one looks okay. Each one seems good, but the collection seems improbable. In other words, there are too many of these considering the reference distribution that we have. And the final thing is behaviors, sequences of transactions, so that we can start to see when sequences don't look right. People are doing strange things, in other words. And as I said, out of these things, then there's a user interface that talks to people and says, look, I found this, what do you think about this? And if they say, well, look, that's a bad thing, we can create B cells that bind to those transaction attributes and then forevermore make definite detections, not anomalies, but definite detections. And we've also managed to write some code in there that avoids autoimmune diseases. In other words, so if a B cell detects something that's not a problem, then the user of the system can say, well, this transaction is not a problem, and then the system retrieves that B cell and reshapes the B cell so that it still detects what it needs to detect, but lets that transaction through. In some cases, that means we have to split the B cell, but that's okay. So I'm just going to talk about the first case study here, which is the cybersecurity case studies. There's a digital advertising one, but we won't do that today. So in this case, it turns out, and I didn't know this beforehand, but there are software development kits for cyber attacks that people can buy. And if you pay a little bit more money, it includes help desk access to these things. So you can actually get a software development kit to go and wreak havoc the websites across the world. It seems a strange thing to want to do, but people do this all the time. So actors apparently attack websites mostly to steal information, either just to steal the information or to steal information and then extract some ransom from people for doing this. So we did a project in collaboration with a cybersecurity company, which is a very large cybersecurity company, but there are some people in there who are ex-military special forces, and they think about this thing in a very different way. And they're interesting people too. I like these people. But in this case, we decided to do a project together where they supplied us web traffic data from what they think was a well-defended site. You know, it has virus detection software, it has network firewalls, and this is an organization which I think everybody would recognize as a household name. We used 3 weeks of web traffic logs for this, and we used our artificial immune system. We created some predictor variables out of this web traffic logs, and we put it in the artificial immune system, and then we sent back the top 20 anomalies that we detected with the artificial immune system. And probably you can't see this very well, but it's a summary slide below. Out of the top 20 anomalies, you can see that they're color-coded. The red ones at the bottom are obviously really big problems. The green ones are normal behavior, but different kind of users who are either developers on this website or users who were administrators on this website. So they had kind of different behavior from all the other people using this website, which is why we pulled them out, but they're actually okay. The yellow ones are somewhat, you can see there's 2 of them up the top, and at this stage, the person that we were dealing with out of this organization, which was a person called Agent Smith. Agent Smith did all the investigation of this, and he concluded that the 2 yellow ones at the top were probably brute force password attacks. In other words, people trying to get passwords out of the system by using a brute force approach. The orange ones are attacks themselves, but they were actually defended by their infrastructure that they had there at the time. The bottom 2 are attacks that went straight through everything and that compromised their website, and they stole information. And you can see one is naively from Singapore and another one is naively from South Africa. But the IPs behind all this, Agent Smith tells me after some investigation, were from Russia. So in summary, and this is a summary that we've got. So out of 20 things that we found, 9 turn out to be normal, and they're safe users, and they could be added to a safe user list, essentially. 2 are unsure, but probably they're possible attacks, but the website wasn't compromised. 7 are definite attacks, but they were defended by the website, and 2 were attacks that breached both the virus detection software and all the firewalls, and these people look like they stole information from this particular website. So that's where I want to stop, because I don't want to go over my time very much, but I'm hoping that gives you an idea what naive people like us could do, given some interesting project to do, and we're an SME, given some interesting projects to do and access to data like this, and a bit of time to build a novel form of machine learning.
Thank you very much for the presentation, Paul. Nice. The slides you showed, you had some interesting results there where you sort of looked at 3 weeks data and you were able to identify some of these attacks that went right through. Now, what was the organization doing incorrectly, or maybe what software were they using that was allowing these attacks to go through, that you were able to detect based on just 3 weeks of data?
Well, they gave us 3 weeks of data that they thought something happened in.
Right.
So that was a test to see whether, and they didn't know these attacks had occurred, but they thought something had happened, but they didn't know what it was. So they were very surprised when we found those 2 red things that were coded red. And after this, they developed a defense against this particular type of attack very quickly. But they hadn't, as I said, they thought they knew that something had happened, but they didn't know what it was. So being able to find these things allowed them to determine exactly what happened and to develop a defense.
Right. And so you sort of take this artificial immune system approach to the solutions you're building now, and obviously you've sort of worked previously in insurance, and now you've sort of applied this to the cybersecurity domain. Now, the system that you've built, how easily can you sort of apply this to across domains? Or
so right now it's being deployed by insurance companies to detect claim fraud. Yeah. So that and that's the domain that we initially thought we would apply it in, that and banking. Because there's lots of banking transactions that are not defended by firewalls and things, that they're kind of interbank transactions and transactions done by people within banks. And so that's where we thought we would initially target use of the system. But it turns out that insurance companies want to use the system as well to defend against claim fraud. Because as soon as they find some claim fraud, they shut that down because they can detect it. They write rules in their administration systems, but then, of course, the people who have been detected, then they figure out a new way to actually perpetrate a fraud. And so this is the means of attempting to find different activity in those circumstances.
And all the companies that you work with, are these SMEs or are the bigger companies?
So this particular company that's got this website, as I said, this website's a household name. It's a very large organisation. And we haven't done any more work with this large organisation. We're only a small company, so we're not capable of doing that. But we have lots of contacts within the insurance industry, and that's essentially where this is going now. People are using it to defend themselves against claim fraud. It's initially motor claims fraud. Yeah.